Yes, I'm here to present video lecture 11. Under this video, chapter 4, asphalt mix design is going to be presented. The first topic under this chapter is purpose of asphalt mix design. Asphalt mix design is a crucial process that involves determining the right combination of materials to create durable and long-lasting pavement. It is a complex science and consider various factors such as traffic volume, climatic condition, and desirable performance characteristics. The primary goal of the asphalt mix design is to create a pavement mixture that offers optimal durability, skid resistance, flexibility, and fatigue resistance. By carefully selecting the right proportion of aggregate, asphalt binder, and additives, engineer can develop a pavement that meets specific project requirements. Through rigorous testing and analysis, engineers can fine-tune the asphalt mix design to achieve the desired property, such as rooting resistance, crack resistance, and overall performance. And this ensures that the pavement can withstand heavy traffic load and harsh weathering conditions for years to come. In general, asphalt mix design plays a vital role in creating resilient and high-quality roadways that connect, communicate, and facilitate safe and efficient transportation. It is a meticulous process that combines science, engineering, and innovation to pave the way for a better future. Let's see the different components of asphalt mix design. The following are the key components of asphalt mix design, which are selection of aggregate, selection of aggregate gradation, proportioning of aggregate to meet the required gradation, selection of bitumen, preparation of specimen, density void analysis, measurement of stability and flow, and determination of the optimum bitumen content. Binders, like asphalt cement, acts as the glue that holds the aggregate together and providing flexibility and preventing cracking. The selection of the appropriate binder is crucial in ensuring the desired performance of the asphalt pavement. Air voids are another important components of asphalt mix design. These tiny spaces within the mixture allow for proper drainage, thermal expansion, and flexibility, and ultimately enhancing the durability and longevity of the pavement. By carefully analyzing the properties of each component and adjusting their proportion, engineers can create an important mix that meets the specific requirements of the project, whether it is highway, parking lot, or airport runway. Now let us proceed to the aggregate selection in asphalt mix design. When designing an asphalt mix, the aggregate plays a vital role in determining the performance and durability of the pavement. The aggregate provides stability and strength to the asphalt mix, as well as contribute to its resistance to wear and weathering. To design an effective asphalt mix, several factors related to aggregates need to be considered. This includes the gradation of the aggregate, which refers to the distribution of particle size within the mix, and a well-graded aggregate blend ensure proper compaction and stability of the mix. Another important factor is the shape and texture of the aggregate particles. Angular and rough textured aggregates provides better interlocking and adhesion with the asphalt binder and enhancing the overall strength of the mix. The type of source of aggregate also play a vital role in the mix design. Different types of aggregates such as crushed stone, gravel, or sand have varying properties that can impact the performance of the asphalt mix. In addition to these factors, the moisture content and specific gravity of aggregate must carefully considered during mix design to achieve the desired proportion of the final products. By carefully selecting and evaluating the aggregate components of an asphalt mix, engineers can create a durable and high-performing pavement that meets the required specification for construction project. Now let us proceed to the selection of aggregate gradation. When it comes to the asphalt mix design, the selection of aggregate gradation plays a crucial role in determining the performance and durability of the pavement. Aggregate gradation refers to the distribution of particle size within the aggregate mix. It is typically represented in terms of particle size distribution curve, such as Fuller curve or gradation curve. The selection of aggregate gradation is important becomes because it directly influences the workability, stability, and compactability of the asphalt mix. A well-graded aggregate mix helps to achieve a dense and impermeable pavement, which is essential for withstanding the stress and strain imposed by traffic. There are several factors to consider when choosing the aggregate gradation for asphalt mix design. This includes type of aggregate, traffic load, climate condition, and desired pavement performance requirements. It is important to strike a balance between coarse and fine aggregate to ensure proper packing and interlocking of particles in the mix. In general, a well-graded aggregate mix should contain a large range of particle size includes coarse, intermediate, and fine aggregates. The distribution of this size should follow a defined gradation curve that meets the specified design requirements for asphalt pavement. In general, the selection of aggregate gradation is a critical step in the asphalt mix design process. By choosing the right mix of aggregate size, engineers can optimize the performance and longevity of the pavement and ensuring a smooth and durable surface for motorists. Now let us proceed to the proportioning of aggregate to meet the required gradation. Asphalt mix design is a critical process in ensuring the quality and performance of asphalt pavement. One key aspect of mix design is the proportioning of aggregate to achieve the desired gradation. The first step in proportioning aggregate for asphalt mix design is to determine the specific requirements of the asphalt the project and including the type of asphalt mix, traffic volume, and the environmental conditions. The aggregates are typically categorized into fine aggregates such as sand and coarser aggregates such as crushed stone and gravel. The proportioning of these aggregates will vary depending on the desired gradation. To achieve the required gradation, the aggregates are typically combined in specific proportion. This can be done using variety of methods, including the use of sieve to separate the aggregate into different size fractions. It is important to ensure that the combined aggregate meets the specific specification for the desired gradation. This may involve adjusting the proportion of different aggregates to achieve the desired mix. In general, proper proportioning of aggregate is essential in asphalt mix design to ensure optimal performance and durability of the asphalt pavement. By carefully selecting and combining aggregates, engineers can create asphalt mix that meet the specific requirements of each project. Now let us proceed to the selection of bitumen. In asphalt mix design, bitumen plays a crucial role as it binds the various components together to form a durable and functional pavement. The selection of right type of pavement is essential to ensure the quality and performance of the asphalt mix. Several factors need to be considered when choosing asphalt or bitumen for a particular asphalt mix design. Factors to be considered: climate and environmental conditions. The climate of the region where the pavement will be constructed greatly influences the choice of bitumen. For cold region, a softer grade of bitumen is preferred to ensure flexibility in low temperature. In hot climates, a harder grade of bitumen is chosen to resist deformation under high temperature. Second, traffic volume and load. The volume and type of traffic that the pavement will experience are important factors in selecting the appropriate bitumen. Higher traffic loads require a stronger and more resilient bitumen to withstand the stress imposed by the vehicles. Aggregate characteristics. The properties of the aggregate used in the asphalt mix also impact the choice of bitumen. The compatibility between the bitumen and aggregate is crucial for achieving good adhesion and cohesion in the mix. Durability and longevity. The durability and longevity of the pavement are key considerations when selecting bitumen. A high quality bitumen with good aging resistance and durability can enhance the lifespan of the pavement. In conclusion, the selection of bitumen in asphalt mix design is a critical aspect that directly affects the performance and longevity of the pavement. By considering factors such as climate, traffic volume, aggregate characteristics, and durability, engineers can choose the most suitable bitumen for a given project. Now let us proceed to the preparation of specimen for asphalt mix design. In the field of civil engineering, asphalt mix design is crucial for designing durable and long-lasting roads. One key aspect of the asphalt mix design is preparation of the specimen for testing, which help determining the quality and performance of the asphalt mix. The material needs for the preparation of specimen for asphalt mix design are aggregate, coarse and fine aggregate, asphalt binder, mineral filler, and testing equipment like Marshall stability machine, compaction mold, and other accessories. Procedures for preparing specimen for asphalt mix design. First, select the aggregate components according to the mix design specifications, ensuring that they meet a gradation requirement. Second, heat asphalt binder to the specified temperature in heated container to ensure proper mixing and adhesion with the aggregate. Third, weight the mix weight and mix the aggregate components in the desired proportion in a mixing bowl. Fourth, gradually add the heated asphalt binder to aggregate mixture while constantly stirring to achieve the homogeneous mix. Fifth, add the mineral filler to the mix and continue mixing until a uniform consistency is achieved. Six, place the mixture in the compaction mold and compact it using a compaction hammer or machine to achieve the desired density and air void content. 7. Allow the specimen to cool and cure for the specified period before conducting performance tests, such as Marshall stability, flow, and density. In general, the preparation of specimen for asphalt mix design is critical step in ensuring the quality and durability of asphalt pavement. Proper mixing, compaction, and testing procedures are essential to achieve optimal performance and longevity of the pavement. By following the specified procedures and using quality materials, engineers can design asphalt mixture that withstand environmental and traffic conditions effectively. Density void analysis. Density void analysis is the crucial aspect of asphalt mix design that determines the quality and performance of the material. By calculating the density and void content of an asphalt mix, engineers can ensure that it meets the required specification for durability, stability, and resistance to moisture damage. To conduct a density void analysis, sample of the asphalt mix are taken from a construction site or production factory and tested in a laboratory testing. The first step is to determine the bulk specific gravity of the sample, which is the ratio of the mass of the sample to the volume of water displaced by the sample. Next, the maximum specific gravity of the asphalt mix is determined by saturating the sample with a known amount of water and measuring its mass. The bulk specific gravity and maximum specific gravity are used to calculate the air void content of the asphalt mix, which indicates the amount of air trapped within the material. The void in the aggregate VMA and void filled with asphalt VFA are also calculated to assess the overall compactness and quality of the mix. By analyzing these parameters, engineers can make adjustments to the mix design to optimize performance and ensure long-term durability. In general, density void analysis is an essential part of asphalt mix design that helps engineers achieve the desired properties of construction projects. By carefully evaluating the density, void content, and other parameters of the mix, engineers can ensure that the asphalt will perform well in various environmental conditions and provide long-lasting results. Now, let us proceed to the measurement of stability and flow in asphalt mix. Stability is typically measured using the Marshall method, which involves compacting a sample of the asphalt mix at a specific temperature and load. The stability value is calculated by determining the maximum load that the sample can withstand before failure, and higher stability value indicates better resistance to deformation. Flow measurement. Flow, also known as flow value or flow index, is a measure of the deformation of asphalt mix during compaction. It is determined by measuring the deformation of the sample under a specified load and temperature condition. A higher flow value indicates greater workability and ease of compaction. Let's see, let's see the importance of stability and flow. The stability and flow characteristics of an asphalt mix directly impact its performance on the road. A mix with high stability and appropriate flow properties is more likely to withstand heavy traffic load, resist routing, and maintaining its structural integrity over time. Conversely, low stability or improper flow can lead to premature pavement failure and maintenance issues. In general, the measurement of stability and flow is essential in asphalt mix design to ensure the durability and longevity of the pavement. By accurately assessing these properties during design process, engineers can create asphalt mix that meets performance requirement and provides a safe and smooth driving surface for road users. Determining the optimum bitumen content. In the world of pavement engineering, determining the optimum bitumen content is crucial in the asphalt mix design. Let us take a closer look at how this is done. The first step in determining the optimum bitumen content is to prepare a series of test samples with varying bitumen content. These samples are then subjected to a series of tests to evaluate their performance characteristics, such as stability, flow, and density. By analyzing the result of these tests, we can determine the ideal bitumen content that will provide the desired performance and durability for the asphalt mix. Finding the optimum bitumen content is crucial in ensuring that the asphalt mix meets the specified requirements for strength, durability, and resistance to various factors like traffic load and weather conditions. After carefully analyze and testing, we have determined the optimum bitumen content for the particular asphalt mix design. This information will now be used to produce high quality asphalt pavement for various construction projects. Now let us see the heaven mix design. The heaven mix design method is a popular method used for designing asphalt concrete mix. Developed by Francis Heaven in 1930s, this method focused on determining the optimum asphalt content for specific aggregate blend to achieve the desired performance characteristics. The Heaven mix design method involves a series of laboratory tests to assess the properties of aggregate and asphalt binder, as well as the resulting mix. This test includes determining the aggregate gradation, asphalt content, stability, flow, and ergoids. By adjusting the asphalt content and aggregate gradation, the Heaven method aims to produce a mix that is durable, stable, and resists to rotting and cracking. The method relies on empirical relationship between the mix proportion and performance on the road. In general, Heaven mix design method is a matrix approach, a systematic approach to create asphalt concrete mix that meets specific performance requirements, making it a valuable tool for engineering and designers in the asphalt industry. The basic philosophy surrounded by the Heaven method. The Heaven method is a widely used technique in pavement design and construction. It is based on the fundamental philosophy of analyzing and designing pavement structure to ensure long-term durability and performance. The main principles of Heaven method includes understanding the behavior of materials. The Heaven method emphasizes this importance of understanding the property and behavior of different pavement materials, such as aggregate, asphalt binder, and additives. By analyzing these materials, engineers can make informed decisions about the design and construction of pavement. Second, optimizing pavement design. The Heaven method focuses on optimizing the design of pavement structure to ensure that they can withstand the traffic load and environmental conditions they will be adjusted to. By conducting or considering factors such as traffic, volume, soil condition, and climate, engineers can determine the most appropriate design for a specific project. Quality control and assurance. The Heaven method places a strong emphasis on quality control and assurance during the construction process. In general, Heaven method is grounded in the belief that the thorough understanding of materials and designing principles is essential for the successful construction and maintenance of the durable and high performing pavements. Thank you for your attention. This is enough for today.